Cool. So what I'd like to do today is I would like to program in processing a kind of space scene that we might be able to start animating and start getting to grips with using the animation function of processing in a way that is really simple but looks really impressive. So I want to approach this in a way that is very simple to begin with and then maybe build some complexity. So I've got my first function, my setup function, which we always start with. And if you've watched a few of these videos already, you'll know that I tend to put this set location thingy just so that my window over on this side always stays in the same position. I might just nudge it over slightly more. So let's do 730, 735, and that will almost, let's try 40. 740. Okay, and you can see that this just positions the window on my screen so that it starts in the same position every time. If you want to use this code, you can, but your location here, your X and your Y position might have to be changed slightly to suit your screen. But this suits mine pretty well. Actually, I can make it a little taller as well. Maybe I'll just do 880. This is such a waste of your time, but it needs to happen. Okay, that'll do. So I've got my setup function. I'm also going to put in my draw function. So void draw, and this is where we are going to be running code in here 60 times a second. And if we code it badly, then it might not run that quickly, but it should be fine. Now, actually, we're not going to draw anything in this loop just yet. We're going to put our drawing in setup. So we're going to draw a background, a nice black background. So backgrounds, we're going to draw it as 0. So 0 being the absence of color. There's no color in there whatsoever, so it'll draw black. And what I'd like to do is I'd like to add some stars, and we can do that by using the point function. So if I said point 100, 100, just to check this out and hit play, I can say backgrounds, and I've drawn a point. Now it's probably black, so I think I might need to give it a stroke, and I might need to say like 255 for white. Let's see if that works. Okay, great. I think if that's not something that's on my screen, that is my point there. Great. Let's try and add a stroke weight. So stroke weight, and I'll just do 10. So this will make it much thicker and easier to see. Okay, yeah, so clearly got a point drawn on the screen there. And if I was to drop that down to 1, we can go back to how small it was to begin with, that tiny little point. Okay, so we can control the color of our stars using stroke, the how big they are using stroke weight, and then we can choose where to draw them by giving it an X position and a Y position. Now, coordinates in processing start at 0, 0 in the top left-hand corner, and then the X gets progressively bigger as you go from left to right, and the Y gets progressively bigger as you go from top to bottom. And what values does it go to? Well, it goes to the value you set in size. So this will go from 0 in the top left here, all the way to 700 on the right hand side for an X position, and it will go from 0 up at the top down to 870 for the Y position. Okay, so they are your coordinate space there. Now, instead of just drawing one point, what I'd like to do is I'd like to draw lots of points. So we're going to just up the stroke weight just a little bit, just so that we can see it clearly. And then let's do a good old for loop. So a for loop allows us to tell the program to do something a certain amount of times. So I'm going to tell it for integer I is equal to 0. I is less than, let's pick 100. Just, it's fairly arbitrary right now. I plus plus. So we're saying we want to create a variable called I and set it to 0. All the time that I is less than 100, you can run this code. And each time you run it, you're going to add 1 to I. Plus plus stands for add 1. And every time we add 1 to I, it's going to get closer to 100 until it is 100, and then I will no longer be less than 100, and so this loop will stop running. And so instead of drawing our point up here, we're going to draw our point down here. But instead of drawing it 100, 100, if I just did that, it's just going to draw 100 points in that position. Okay, that's not great. What we want to do is we want to pick a float x equals random and float y equals random, and we are going to draw our point at x and y. Now we need to put a number in those brackets in order for it to pick a random number. So we want to pick a random number, and if we just put one number in here, it will assume that we want to go from 0 up to that number, a random number, anywhere between that range. So we're going to go from x all the way to width. Sorry, we're going to go from 0 all the way to width. So we want to pick an x position that's a random number from 0, so right at the start of our canvas, all the way up to however wide our screen is. I've set it to 700 here, but later if I want to put it into full screen, by using width rather than 700, it allows me to dynamically scale my project or shrink it down without having to do much to change all the code. And so you might have guessed by now that float y is going to be equal to random and height. And so this will be a random number from between 0 and all the way down to the bottom. And so when we draw our point, it will be a random location somewhere on the screen using x and y. And now if I hit play, you can see we have loads of stars. Cool. So now we've been able to kind of generate this field of stars. Maybe what I'll do is I will, instead of saying the stroke weight is 5 up here, let's pop down here and let's say float weight, weight equals random between 0 and 5. And then let's put weight in. Cool, so now we've got some kind of variance in their sizes. Maybe what we could do as well is change the color of their stroke. So if I take that from there and pop it down here, so I'm going to say float color, spelt the English way, equals, and maybe I'll do from between 100 and 255. So they can be a kind of darker, grayer color. And then instead of saying stroke 255, I will say stroke color, and I'll use the color that we pick. Oh, I need to put random here, random. And now when I hit play, we don't just have kind of stars that are all the same color. It now starts to look a bit more realistic and a bit more like a starry night rather than just a load of circles on the screen. If we go back to what we had before, so if I comment these out and pop these back up here, if we have what we had before with just 255 and a stroke weight of 5, then you can see that this just looks very, very basic. Whereas down here, we can see that this really transforms it, really makes it look better. And you can see that because I've said stroke and stroke weight down here, it doesn't matter what I set them to up here because it's overwriting it down here. But I'm going to get rid of these because they're unnecessary. Okay, so we've got ourselves some stars and we started looking at how they could be different to each other. Now what I'd like to do is create a relationship between how big they are and what colour they are. So when we pick their weight, what I'd actually like to do, this can be any number between 1 and 5. So what I would like to do is do 255 divided by 5. So let's just print line 255 divided by 5. Just use this as a quick calculator. Okay, 51. So what I would like to do is my colour will, instead of equaling 100 and 255, it's going to be 51 times the weight, which could be up to 5. And if it is 5, it will give me a total of 255. And so now, the further away they are, the darker they will be. The closer they are, the bigger they are, the brighter they will be. And now when I hit play, I didn't put a semicolon there. Let's try that again. When I hit play, I now have those that are bigger are brighter and those that are smaller are darker, which makes a lot of sense. And I can change this weight to be actually what I need to do is I need to set a variable. Let's set a int max weight equals 10. Okay, and then actually I'll just do 5 for now just so it's clear. So instead of putting 5 in here, I'm going to put maximum weight. And so instead of having to divide 255 by 5 and then find out it's 51, I'll get it to work it out itself. So I would say 255 divided by the maximum weight times whatever weight was picked. And this way we can generate a colour that is representative of the range of weights that we can have. So if I hit play now, we shouldn't really see much change. It should be fairly similar. But now this allows me to change the maximum weight, the bigger they can be. So they can now be double the size that they are currently. And it allows me to keep that range of colours going. So this is probably a little bit big. I probably don't want them to be this big. But I think that's about as far as we're going to go in terms of generating stars in this way. Now, this is all very good, but if I wanted to actually animate these, then I need to know the position of all of these stars in able to be able to add to that position or take from that position to get them moving. And so really what I need to do is I need to, instead of just drawing a point, I need to create a class that can store this data and be looked back through and kind of drawn over and over and over again. At the moment, we're just drawing in setup. If I was to put all of this, actually, let's get rid of print line. We don't need that. If I was to put all of this in draw, they would not animate. We would get lots and lots of rapidly changing scenes. Let's hit play. Okay, and it's drawing over itself because I didn't put background in draw. So let's pop that there. And so now you can see that we just get this kind of chaos, utter chaos. It looks a bit like when back in the day when your TV aerial kind of went out and you just got static. Maybe let's try 1,000. See what we get there. Yeah, this is pretty insane. This is not good. So what we want to do is we want to create the idea of a star. So I'm going to create a new tab and I'm going to create a star file. Okay, and I'm going to say I'm going to have a class called star, and we're going to say every time we make a new star, we are going to give it. Oh, we're going to give it a. Or are we? Do we need to? Maybe we don't. Maybe we could just get it to pick its own. Yeah, let's get it to pick its own. So we're going to say this dot. We're going to make a p vector. A p vector is a data type in processing that allows you to store an x and a y position inside it. So I'm going to say p vector position, or p vector pos for short. And if you've seen other videos, this is kind of something that I always do. So this dot pos equals new p vector. And let's go and steal some code. So float x, float y. Let's just grab that. So from this for loop that I put into draw, when we pick our random width and random height from x and y, I'm going to cut that and I'm going to pop it into here. So float x, float y, and then new p vector with x and y. Now if I really wanted to make this simpler, I could just take this and replace x in here with that, and I could take this and I could replace y with that, and I could get rid of this and do it in one line, which makes it maybe a little bit nicer. So I'm picking a random x position and a random y position. Now this star is also going to have a size. So let's do a float called size, and this dot size is going to be equal to let's put this as a global variable. So up here, let's say int max weight equals 10. Let's get rid of this. And we're going to say this dot size equals random from max weight. So from 0 up to max weight. So that's going to be the size of our star. Now we've got our color, which is going to be just like this. So let's take that, and we're going to have a float color, and our color is going to be, instead of times in weight, we're going to use our size. Okay, so that is this dot size. Now we obviously stroke weight is the function, that's why I called it weight over here, but actually we're talking about the size of the star, so really the variable should be named size. So we're going to do the maximum weight, which we've defined up here globally so that everything can see it, and we're going to multiply the 255 divided by max weight, multiply it by this dot size, and that will give us our color of our star. Now when we display our star, we're just going to use this code here. So I'm going to take this and I'm going to cut it, and I'm going to tell the star how to display. So I'm going to say void display, and the way we display is we do stroke with this dot color, we do stroke weight with this dot size, and then we draw us our point at this dot pos dot x, this dot pos dot y. And that's how we display our stars. Now we create our position, our size, and our color. I've put float color, this needs to be this dot color. We assign those all at the start of the star, and once a star is made, this number stays and it stays put. Okay. Now what we're going to do is we're going to tell the star. Well, no, actually, let's not get ahead of ourselves. Let's just make sure this works. So at the moment, if I hit play, it will tell me that I've not put in enough semicolons. At the moment, if I hit play, nothing happens. Okay, so we've moved all of our functionality into this new class called star. So what we're going to do now is we're going to generate new stars. So we need to create an array list to hold them all, because we need some way of being able to keep track of all of them. And that array list is going to be full of the data type star, the one that we've made. We've made a class called star, and we're going to fill our array list with stars, and we're going to call it stars. And it's going to be equal to a new array list of data type star, and we're going to put rounded brackets at the end in order to say make this. Okay, so now instead of drawing stars up here, we're going to in setup, we're going to say for int I equals 0, I is less than 1,000. Let's do 100 just for now, just for testing purposes. We're going to say star equals new star, and then we're going to say stars dot add our star. So we want to add our star to the array of stars, and that will add in our star. Now, if we kind of try and keep this nice and separate, so if I hit play now, still nothing happening. Well, what's going on? Well, we've added all of these stars to this array list, but we're not actually telling the stars to display. We've written a function, a method for how they should display, but we are not actually calling that. So what we need to do now is we need to in draw, every time we draw, we need to say for star s in, and the colon stands for in, stars. We're going to say s.display, and that will draw our star. Lovely. Okay, now we have stars. So we've told it, we're telling all the stars in our stars array, for every single star in that array, tell that star to display. Next star, tell it to display. Next star, tell it to display. And it will tell them all to display. Now what we want to do, now that we are displaying them and we're able to kind of give them a direction, now we want to get them to move. So I'm going to say void move, and we're going to give a p vector, because this makes it super easy, and we're going to say direction. And we're going to say this.pos.add direction, and that will add on whatever direction we give to our star. So now if I hit play, nothing's going to happen, still the same old code. But now if I come down here, I can say s.move, and let's give it a p vector. So direction equals, p vector direction equals new p vector, and let's tell it to move positive 2 in the x direction and negative 1 in the y direction. And now we want to pass in that direction to our move, because when we move a star, we need to pass it a p vector. And so we're passing it a p vector. We made a p vector, called it direction, and we popped it in here. Now we could have called this just anything. We could have called this d. Okay. The fact that it's called direction here, these two have to match, these two here, but it doesn't mean that we have to call what we pass into it direction. It will just take whatever d is and then assign it to the value direction. So now if we hit play, we have some moving stars. Look at that. Okay, cool. So that was kind of good, but now they've all gone off the screen, which isn't so great. So what we need to think about now is how we can get the stars to check their position, and if they have gone off the screen, maybe send them to the other side. Okay, so we can do a little check. So in our move function, we can say if this dot pos dot x is greater than width, we're going to do something. Else, if this dot pos dot x is less than 0, we're going to do something. Else, no, not else. We need to just leave it there. And then we're going to have a separate if statement. And we're going to say if this dot pos dot y is greater than height, else if this dot brackets if this dot pos dot y is less than 0. So we want to check whether we are off the screen and off the screen on what side. So if we're off the screen on the right hand side, so if we're greater than width, then we're going to edit our x position. So we're going to say this dot pos dot x equals, and let's say something like -50 to reset it over the other side. Now what we're going to do is we're going to do the same thing, but if it's come off the left hand side, we want it to come back onto the right hand side. So we want to just flip it across. So we're going to make that height plus 50, and not a fan of this 50, so I'm going to put in a int called buffer. Let's call it margin. Int margin, and so that equal to 50. And then everywhere that I want to use margin, I can just say this dot margin. And you can just whack a minus in front of a number and it becomes a minus number. So I'm going to say, I'm going to keep height, but I'm going to say add this dot margin. And now we're going to do the same, sorry, this should be width because we're dealing with the x domain. So we're dealing with the width. And now I can just copy this and paste it into if this dot pos dot y is greater than height. And I can just change this to this dot pos dot y equals minus this dot margin, and then I can take this, copy this, and paste it into here. And if this dot pos dot y equals height, add this dot margin. Lovely. So we've been able to tell the colors, tell the stars how they should move. So let's hit play. Okay, great. Wait, that's not so great. What's going on? They're not coming back. This dot pos dot add direction. If this dot pos dot x is greater than width, this dot pos dot x equals minus this dot margin. This dot pos dot x is less than 0. Oh, I've put them in like an infinite loop. That was dumb. So instead of doing, okay, so if this dot pos dot x is greater than width, add this dot margin. If this dot pos dot x is less than 0 minus this dot margin, and then if this dot pos dot y is greater than height, add this dot margin. I should have just used, oh well, too late now. And if this dot pos dot y is less than 0 minus this dot margin. Okay, lovely. So we've got them coming back onto the screen now, and you can see they're just kind of drifting around. Now, one thing that's making this look super unrealistic right now is that they are all moving at different speeds. And so I'd like to change that. So the further away they are, the slower they will be moving. Okay, if you're driving down the road, the things that are very close to you, like streetlights, will be flying past you, but mountains or hills in the distance won't be kind of flying past you. They'll be moving very slowly. And so we need to apply the same principle here. So our size is going to have an effect on our speed. So we're going to make a float speed, and we're going to say that speed, this dot speed is equal. Now, this dot speed is going to be faster the bigger it is. So what was max weight? 10. I'm going to use a map function. So I'm going to say this dot speed equals map. And we are going to map this dot size, which goes from anywhere between 0 and max weight. And we want to constrain that between two values. So I'm going to do maybe between 1 and 3. And what I might do up here actually is make a int top speed. And so we can change that later and put that as 3. And then up here, I can just copy that and pop that here. So this dot top speed. And so later on, I might decide that the top speed is too much or too little, and I can change that as and when I see fit. And so down here, when we add our direction, we are going to first multiply that direction. So we're going to say direction dot mult by this dot speed, and then we're going to add our direction. And so now we should get a variety of different speeds. Can you see that? We've got this kind of 3D effect now, which is really cool. Now we're blipping along at quite some speed, and actually I think that what I need to do is I need to maybe map this between 0 and make the top speed 2. Okay, that's cool. Now what happens if I make more stars? So let's do 1,000 stars and see what that looks like. Okay, so you can see that this has now created the kind of illusion of 3D space. Because the things at the back are moving a lot slower than the things at the front, it really feels like there is some depth there. We've got a 2D canvas where we're just moving circles, but actually we've got something really quite cool going on here where we've got this three-dimensional effect. Because we are moving the circles at different speeds relative to each other, we are actually creating this really interesting effect. Now down here, my direction, I can change this in order to kind of change how these are moving. So if I didn't want them to be going on this diagonal, if I wanted them just to be going straight, I could just keep an x position of 2. So keep moving it 2 across in the x direction, but move it 0 in the y direction. And then when I hit play, we now have it going straight across. I could slow it down by doing 1 and 0. So now you can see it's much slower. Now one thing I'd like to do before I finish is add some alpha to these. So let's so when we draw our stroke, let's do this dot color, this dot color, this dot color, and this dot color. So using one this dot color is the same as using 3 this dot colors, because if you use 3 of the same color value in an RGB color, you just get a grayscale value. So if I had 100 green, 100 red, 100 green, 100 blue, it's the same as I would get a gray color. Adding a fourth argument changes how transparent these are. So let's see if this has any effect. So you might be able to notice that they are slightly kind of grayed out. They're very faint. The ones at the end are very, very faint compared to the ones at the start, which are very bright. Not only have we got some kind of grayscale going on, we've got their actual transparency is being changed as well. Now, if I was to just as an experiment, do 0, 0, 0, and then do like 1 for the alpha, how does that change our... No, it doesn't change anything. What if I did 0? No, okay, okay. I thought that might change something, but apparently not. Let's just leave that at 0. So we have created this kind of cool looking star field, and we've got it moving around. Now, one thing you could do to take this further is maybe look at having a key pressed. So maybe actually let's do that, because that's quite an interesting idea. So let's say that p vector d, let's cut that and let's put it up here. So that is defined right at the start. Now what I'm going to do is I'm going to say function, no, not function, no, void, sorry, void key pressed. That's a built-in function to processing, so it picks up anytime a key is pressed. And I'm going to say if the key that is pressed, it automatically gives you the key. So if key is equal to, and I'm going to use W, then I would like to say that D equals a new P vector. No, I don't. I'm going to say D equals D dot add. Yeah, let's be clever about this. Let's make a P vector called change. And we're going to set that equal to a new P vector. And this vector is going to, so W is going to be my up arrow. So it's going to have 0 influence on the X, but it's going to have a -1 influence on the Y position. And -1 will take us up because Y is 0 at the top. And then we're going to add that change to D. Okay, and then we're going to add that D to our move function, and the stars will move in that direction. So now when I do that and press play, I didn't put a semicolon. When I do that and press play, incompatible. Okay. Key is a character, not a string. So I need to put in single quotes, not double quotes. That's really important in Java, that you put any character data types in single quotes. So now if I hit play, okay, interesting. Let's do this. P vector direction. And then I can say in setup direction equals new P vector and direction, direction, direction. So what I've done is I've changed the variable name to direction just to make it clearer. It's not a very good practice to have just a single letter. In here it's okay because it's in this 4 star in stars and it's just reducing the amount of words of star there. But yeah, D is a bit nondescript. What I've also done is I have declared it in my setup function, but it doesn't seem to like that at all. If key equals W, it's not happy. It's not moving. Why isn't it moving? That's very bizarre. It's like it's not being added. Okay, there's some kind of weird thing happening in the loop where it's not... I need to make this new vector every time. So what I'm going to do is I'm going to create 2 variables that I plug into this. Okay, cool. Okay, so we're back on track. So I'm going to make a float x direction. Let's keep it lowercase. Equals 2 to start with, and I'm going to make a float y direction, and I'm going to set that to 0 to start with. Cool. Okay. So after all that, I can say x direction and y direction. and I can make a vector with those coordinates, and then I can change these numbers, and that should hopefully get our key pressed function working. So let's bring this back into play. So if my key is W, I want to just change my Y direction. So I want to say Y direction minus equals 1. So we go upwards. Else if key equals single quote, let's do S. Then what I'd like to do is say Y direction plus equals 1. Okay, so now I should be able to hit W. Oh, look at that. And I'm making it go really fast upwards, and I should be able to press S and slow it down. Oh, it's like we're traveling through space. Okay, cool. So now you can see I'm setting it down, I'm setting it upwards, and we're kind of drifting along. Now what I can do is I can do A and D as well. So I'm going to say else if key equals A, then what do I want to do? I want to take my X direction and I want to go left. So I want to minus equals 1. And lastly, else if key. Now it's important that I don't just do an else, because I only want this to work for if it's D, not for if it's any other key other than WS or A. So if key equals D, then I want to say my X direction plus equals 1. So I go more to the right. And so now when I hit play, I should be able to properly kind of turn around and zoom through space. And I can go really, really fast. Look at me go. Okay, we're back to basically where we were at the start when we were generating those random patterns of stars over and over again. But I can slow this down, I think. Slow this down. I've gone too fast, I think. There we go. And bring us back to normality. So we've got this star system that we can kind of navigate through. We can slow it down, we can change the direction by using our keys, and we can speed up in one direction, two directions, and also slow it down and reverse the directions. Now, as a last thing, let's just add a few more. So when we make the stars, where do we make them? Here. Let's see what happens if we had 1,000. It's pretty cool. I think 1,000's a bit much. Let's do 500. And there we have it. So that is a little kind of space animation that we've been able to create using objects, using star objects, keeping them in an array, and then drawing them and having them related proportionally to each other so that they actually create some kind of 3D space effect, which I think is really cool. Sweet.